making a video. A broken camera. Anyway, yeah, this one I broke on purpose. Yeah, actually, I took the filter out of it. You know, I guess it's an infrared filter, but I don't know. I think it's an ultraviolet filter. The filter's infrared, but it doesn't really matter. Anyway, just to do an experiment and see. I mean, it should have better night vision now, but I don't know. I think it's got another filter in it, actually. Anyway, I have to work on that. I'll figure it out. Anyway, yeah, I thought I'd do a physics video. Yeah, that's a good idea, physics. Anyway, Piero was talking about this shit, so I'll do a quick video. Because I just want to start the conversation in some sort of way. So anyway, participation kind of... Oh, my hair is just terrible. Oh, this thing is supposed to be sticking. It doesn't stick. I have to make it stickier or something. Anyway, it really is irritating. They don't make these cameras for vlogging, you know, at all. You have to modify them to do it right. Anyway, the focus is really fucked up. Wait, I took the lens apart. The focus should be fucked up. Anyway, what was I? Physics. Alright, so, yeah, I'll make some... I'll order them, you know, and you can just say agree or disagree. Such. Ooh, shouldn't have done that. But anyway, come on, this thing stick on here. The glue. I mean, I don't want to make it permanent, but I want to use it on different cameras. The damn thing's supposed to stick. It doesn't stick. Anyway, yeah, this video is really going well. So anyway, so I'll point it out, and then you can say agree or disagree. And I'll just like 1, 2, 3, 4, and you can just say in the comments. So we'll only do 3 or something. 2, 3, I don't know. So my first contention theory, I'm trying to find the right light, would be that let's see, we go with number 1. All right, number 1, that everything in the universe is really quanta. So it does have a finite termination. It is made up of checkers. It is made up of pieces, Legos, whatever you want to think of it as. That there is the smallest thing in the universe, and it doesn't get any smaller. That's it. There's a bit. Alright? There's not people living on it. There's not other worlds living on it. It's not made out of something. It's the something, and nothing gets smaller than that something. Yeah, that's the first statement. And I have no evidence one way or the other on the truth of that one. not off the top of my head. I have an impression, and that's all I have. This is weird looking. Yeah. Anyway, I can put the filter back on. Maybe. Yeah, the filter. This thing's falling off. I can put the filter inside of this thing that doesn't work. Oh shit. Alright, that's not gonna work. Well, never mind the filter. That's for another time. We'll mess around with this thing. Anyway, there's a spot right there too. I got the whatever you call it, dirty when I was taking it apart. Anyway, yeah, this is whatever. It's an experimental camera. It's really a mess. Anyway, where was I? Anyway, that's where I was. All right, so that's the first contention, that there is a divisible thing, and it stops dividing. There's a finite amount of dividing you can do, and that's all. That's the end of the dividing, and you get to what the thing is made out of, and that's it. Yeah, I'm just gonna keep fucking with this thing because it's really pissing me off. Anyway, yeah, well, whatever. All right, sorry, wasting your time with this bullshit. All right, the second one is that I theorize that all these bits are all moving at the speed of light. So everything that the universe is made out of is actually made of little bits moving at the speed of light, little quanta. Even an electron would be like 1 billion quanta moving at the speed of light in all the same direction, you know, within the same vicinity. And that was what we call an electron. Or a photon. Photon might be half as much. And, you know, when you get to like cosmic rays or something, you're talking very few quanta maybe. Maybe just 1 quanta. I don't know, I haven't thought through that one. I mean, maybe something like that is the quanta all by itself, just a quanta. Anyway, alright, so the other, so yeah, it's all moving at the speed of light. And the speed of light provides, if you dissect it into this Planck constant, or the idea that there would be a clock speed, like this one quanta moves one quanta of distance in one quanta of time. And that's so that's number 2, is that it's all moving at the speed of light. And the second contention that goes with that one, 2b, is that it's, well, I shouldn't combine them. Alright, we'll just do the speed of light thing as number 2, and then number 3 will be that it's can be equated with a clock speed, because if there is a quanta of size, there's a quanta of time, and there's a quanta of distance. And all those quantas are all based on the size of a quanta. So one quanta of distance is one quanta of size, is basically you almost think of it as a frame rate. So the universe has a frame rate, and it would be one of those huge numbers like times the speed of light squared, Einstein kind of number, hugely fast frame rate. So this video is at 30 frames a second. The universe would be at, I don't know, 3 zillion frames a second. And so that's why we can't see how much stuttering and reversing and other kind of bullshit it's going on. Like even in this 30 frames a second, let's say this was 30, which it probably isn't, it's probably only 15. But anyway, even at that frame rate, I could fool you. I could put one frame in here from another video. And as long as it's something like this, you might not even notice it. You won't even see it. You just zoom right by, you'll never even see it. Maybe even a blank frame, you'd never even see it. Your eye just wouldn't pick it up. You might just, be a little tiny stutter, a little flicker. And that's all there would be. And that's just at 30. So imagine a very high frame rate. You could sneak in a lot of dopey, frames. You could sneak in all kinds of bizarre crap into the frames, and you wouldn't notice any change in reality. Reality would look exactly the way it looks right now, and you wouldn't be able to detect the fact that everything just moved backwards, before it moved forward. And so that's sort of what number 4 would be, is that all the movement you see in things on our material level, that you can perceive the movement, that it isn't too fast for you to even see, is taking place on a quanta level, because there has to be this relativity has to be maintained. You can't speed something up faster than the speed of light. So if a quanta inside an atom, inside your body, is moving that way, and you're moving that way, or you're moving in the same direction. Let's say you're moving in the same direction as the quanta at any one constant of time, that would multiply, and then you'd end up with something moving faster than the speed of light, which it can't do. So the trick is that your movement is stuttered, is synchronized to the movement of quanta. So you can only move in a direction that the quanta is moving in. All the quanta have to move in the same direction in any one moment of time for you to move. And for them to do that and maintain the structure that they're caught up in requires there to be some kind of mechanism for some sort of time changing or adding thing that allows for there to be that kind of collective movement in a direction, the material movement, without affecting the movement on the scale of the quanta, which are caught up in orbits around gravity wells. Well, anyway, so that's number 4. Let's just stick with that. That's enough. Alright, so 1 was, yeah, it is a material universe. There's no fantasy bullshit of, like it's a solar system and then that solar system is a solar system. It doesn't get smaller and smaller and smaller forever and ever and ever. It's a finite universe, finite material in the universe, finite composition to the energy. Alright, number 2 is that everything in the universe that we call a thing is made up of energy, and all that energy is all just quanta moving at the speed of light that gets trapped in gravity wells called atoms. And number 3, that there's a frame rate essentially based on this sizing issue of quanta time of this and distance, and those things all are related to each other. And 4 was, I don't know. Yeah, I don't remember. 4 was God damn this thing. It seemed like it was kind of important. 4 matter stuff. Oh yeah, the movement thing. Yeah, that's right. That movement requires us to essentially move backward maybe before we can move forward, kind of thing. That when we move our hand like this, our hand really isn't moving in a linear manner like that. On the quantum level, it's waiting for the quanta to be in the right, to be incidentally moving in the right direction. Yeah, there's some sort of lag in there. I have to work that one out. So 4 is just kind of fuzzy. So you're just going to say, okay, the flaw, that fuzziness is, it's interesting, but no, I don't know whether I'm going to go for that. So anyway, there. So participate as you wish. Agree, disagree, something, or nothing. I don't care. Anyway, so till next one of these things. Yeah, I'll try to do it with a camera that actually works. Well, that would be, no, I won't do that. No promises there. No, I'll try to do it where the camera has already arranged to be of consistent functionality for the video, and I won't have to fiddle with it to maintain video production. There, that's what I'll promise. I'm promising. Anyway. So we'll see what this comes out like. I mean, it does HD, but I'm going to cut it down. Obviously, I'm going to webify that HD. But, you know, this doesn't look too bad. But yeah, it does take the, you know, removing the filter has, I think it's enhanced the detail, but it's killed the color, which is interesting. Okay. Science to that too. Button. I gotta hit the button with a. Yeah, forget it. Alright, now I can do it this way.